All around the world, in tropical and subtropical oceans, lies one of the most diverse ecosystems on Earth. Coral reefs are usually found at shallow depths of 50 meters and in warm ocean temperatures between 25 to 28 degrees Celsius. Coral reefs are built by tiny organisms called polyps, which are held together by their calcium carbonate secretions, forming an exoskeleton that houses almost 25% of all marine species. The species that rely on coral reefs include fish, sponges, crustaceans, algae, invertebrates, seabirds, and reptiles. Coral reefs provide an abundance of ecological functions, including nutrient cycling, carbon and nitrogen fixing, and are a source of nitrogen and other essential nutrients. Furthermore, reefs provide shelter and habitats for marine organisms. Reefs also act as a natural barrier from storms and waves by slowing down waves that would otherwise break directly on the shore. Coral reefs also provide a variety of ecosystem services. Examples include the fishing industry. Reefs are also a major area for research in the medical field, contributing to drug discovery and other important medical compounds. Additionally, reefs are important to tourism and fisheries, as well as the cultural and recreational values. However, many of these ecosystem functions and services are now being severely threatened. In 1979, researchers observed extensive damage to 4 large coral reefs around the world. They saw these colorful reefs teeming with marine life turn into lifeless rubble covered in seaweed or slime. These disturbances attracted a lot of attention from researchers who wanted to investigate the causes. Throughout the 80s, researchers concluded that increased ocean temperatures and ocean acidification are the primary causes of coral reef damage. They also discovered that pollution and careless tourism are affecting reef health. As of today, it has been estimated that 20% of existing reefs have been lost and up to 60% are at risk, primarily due to human activities. These effects can account for the major economic and ecological losses already seen in the fishing and tourism industry. Global and regional scale mitigation efforts have been implemented and proposed to reduce human impacts and maintain reef health.
Climate change is the variation in average weather conditions in certain locations, and it is primarily due to anthropogenic greenhouse gas emissions.
It has been recorded that 60% of reefs worldwide have warmed significantly since 1985. As a result, there has been extensive coral bleaching, increased intensity of cyclones, and destruction of marine habitats. Cyclones are intense, low-pressure storms that form over warm oceans, and evidence has shown that they can cause extensive damage to reefs. Surviving organisms are left with little protection from predation, leading to further reduced marine diversity. It is evident in damaged reefs that juvenile fish practice more risky, prone behaviors, such as greater exposure to predation and the inability to react to predation cues. Climate change has been shown to contribute to ocean acidification, which comprises carbon accumulation in water bodies, ultimately decreasing coral populations in reef systems. Ocean acidification is a major threat to reef mortality by reducing calcification rates of polyps, while also affecting the crucial relationship between symbiotic algae and corals. Concentrations of atmospheric carbon dioxide has been expected to exceed more than 500 parts per million, where the usual concentration is between 450 and 500 parts per million, along with a 2-degree rise of global temperatures by 2050 to 2100. When atmospheric carbon dioxide gets taken up by ocean bodies, it reacts with water to form carbonic acid. The oceans are originally slightly basic with a pH around 8.1. However, it has been predicted that by the end of the 21st century, the pH will be reduced by 0.3 to 0.4 pH units. This decrease in pH does not seem like much of a difference, but the pH scale is logarithmic and based on an order of magnitude rather than a linear scale. Therefore, a 0.1 pH unit decrease is equal to a 30% decrease in pH. That is 30% more acidic. This ocean acidification inhibits aragonite formation, which is the crystalline form of calcium carbonate deposited in coral skeletons by polyps, which leads to erosion. Another contributor to coral reef degradation caused by increasing water temperatures is the increase in the abundance of boring sponges, a bioerosion indicator. These organisms weaken reefs by removing calcium carbonate from the coral framework. Boring sponge populations increase in abundance due to increased temperatures, promoting further reef degradation.
Acidification and increased temperature lead to what is known as coral bleaching.
This stress causes corals to expel the endosymbiotic algae, called zooxanthellae, from within their tissue as a means of short-term survival, leading to a white appearance. The algae provides 90% of the energy which the coral allocates towards reproduction, growth, and calcification. Since the algae are providing energy for corals, when expelled, the corals starve, resulting in mortality.
For example, in 1998, after the El Nino and the Indian Ocean Dipole interaction. This is a type of abnormal weather phenomenon that increases ocean temperatures. This bleaching event caused a massive change in the habitat for reef-dependent fisheries, ultimately leading to the reduction of marine diversity.
One of the primary causes of reef degradation is pollution that originates from land-based anthropogenic activities. This includes agriculture runoff, sewage outflow, and sedimentation. The excess of nutrients from agriculture runoff and sewage outflow leads to eutrophication, which increases detrimental algae growth, reducing oxygen concentration. Sedimentation from the erosion due to land clearing from coastal developments hinders the ability of the reefs to reproduce and feed, and sewage runoff introduces pathogens that threaten reef ecosystems. In recent years, anthropogenic recreational activities, such as scuba diving and snorkeling, have become a popular activity along coastal areas. Coral reefs have become more accessible for visitors due to an increase in the tourism industry and improved coastal facilities. Therefore, the number of people diving in coral reef areas has risen. In popular areas, coral colonies are significantly more damaged due to trampling by human visitors. Ocean acidification has major impacts on the economy through the tourism and fishing industries. As the viable habitat decreases, the population of reef-dependent fishes are expected to decrease as well. Tourism accounted for $7.6 trillion annually, about 10% of the world's gross domestic product. However, with the degradation of reef areas and decreasing biodiversity, these fisheries are expected to be negatively impacted. The Philippine reefs, for example, are continuously being destroyed, leading to a decrease in fishing potential, causing a loss with an estimated worth to be $200,000 yearly. Although the tourism industry has the potential to optimize environmental resources by 75% in the next 10 years, an estimated $400,000 loss of tourism potential is correlated with unhealthy reef populations in the Philippines. As ocean temperatures continue to rise due to climate change, it becomes more imperative that the solution to a global issue be met with global support. The United Nations Framework Convention on Climate Change is an international treaty that has resulted in agreements such as the Kyoto Protocol and the Paris Agreements. These agreements highlight that developed countries such as the United States are the primary producers of greenhouse gas emissions, contributing to climate change due to industrial activity over the past century. Therefore, the burden of responsibility is focused on these developed countries to abide by targets to reduce emissions and further prevent the global implication caused by climate change. As a consumer, the simplest way you can reduce your greenhouse gas emissions is to avoid overconsumption, as well as supporting sustainably conscious industries that strive to reduce emissions. We need to diversify the energy market and ultimately move away from fossil fuels to more sustainable energy resources. On a regional scale, focusing mitigation efforts on improving management and policy will better aid in ensuring the persistence of coral reefs. This can be demonstrated through the application of increasing marine protected areas or more prevalent catchment management to reduce the contaminants that cause poor water quality and degrade marine habitats. Targeting point source pollutants such as sewage outflow through tougher environmental regulations and increasing investments into water treatment will prevent the release of toxic untreated sewage. These regulations need to include management practices that focus on the rehabilitation and restoration of coastal wetlands and vegetations as a method to reduce erosion and pollutants that are created from land-based activities from entering marine systems. Locally, efforts to mitigate trampling effects from tourism can consist of limiting recreation areas. Such an approach would minimize biological effects whilst preserving amenity value. A more interventionist approach looks at selecting and propagating coral that are genetically more resilient to acidification and bleaching as a means of restoration for coral reefs. This would entail assisting in the evolutionary process through select breeding, then reclaiming bleached coral reefs with those more adapted to environmental stressors. Studies have shown that this is the most effective method for reef restoration. Coral reefs are a crucial part of the ecosystem as they aid with nutrient cycling such as carbon and nitrogen fixation. Reefs also provide shelter for marine organisms and minimize the damage on coastlines from tropical storms. Rising ocean temperatures due to climate change are leading to global reef degradation. This has resulted in coral bleaching and intense tropical cyclones that increases reef mortality, negatively impacting many organisms that rely on marine habitats provided by coral reefs. Erosion, pollution, and tourism are also contributing to reef degradation, and mitigation efforts are desperately needed to protect and prevent further damage. This can be done by establishing strict regulations on the concentrations of pollutants released into the environment, improving and applying more technological approaches to reef restoration, and restricting tourist access. We need to act now before it gets too late and all the coral reefs are lost.